This particular problem, it says draw Lewis structures for each of the following species. Put them in order from shortest NO bond to longest NO bond. Well, this question deals with the relationship between what we'll call bond order, or average number of bonds, and bond length. And so very basically, the higher the bond order, the shorter the bond. So higher BO, where BO is our abbreviation for bond order, equals shorter bond. And higher bond order equals shorter bond. It also equals stronger bond. So for example, in the last problem, when there was a triple bond between the two carbon atoms, that is a very strong bond. Now, and the problem that you're going to get, and I think this is a homework question that only has one question, so everybody will get the question with that I've crossed out here. So I'm going to work a slightly different, though related question, and I'm going to work it for chlorinated ions, and yeah, all these are all ions. So I'm going to start with A, and if I were to draw the best Lewis structure, because everything starts with best Lewis structures in this week, I would count up the valence electrons, I would put chlorine in the middle, and if I did all these things, well, actually I wonder if I can do this. Well, let's go ahead and do it. So 7 plus 3 times 6 plus 1, 7 for chlorine, 6 for each oxygen, and there are 3 of them, plus 1 electron for the minus charge, 18, 19. I get 26 electrons, 18, 25, yeah. Connect them all by single bonds. Go ahead. Fill in those octets. After all 3 of the oxygens, and this is sometimes a handy hint for me, each of these oxygens has 8 electrons around it. So I know that I've got 8 plus 8 plus 8, or 24 electrons in there already. I can then put in my 25th and 26th. If I do this, I get, and then I do formal charge analysis, I get 3 different minuses and a plus 2. Plus 2, yeah. And then that means to make the best Lewis structure, I'm going to form 2 double bonds. And I get a best Lewis structure that is right here with a negative formal charge on this oxygen. And I forget if I've said this before, but when you draw your best Lewis structure, in addition to having all the bonds, all the atoms, and all the pair of electrons, it will always need to have all non-zero formal charges. And that's what that means. So I'm showing my 1 negative formal charge. And again, that's not surprising because there is a minus charge on the ion, and that minus charge has to be somewhere in the atom.
Professor, you didn't put the valence electron.
Oh, thank you. That seems... Thank you, Daryl. I keep forgetting those electrons on that central atom. Thank you. That should be better now. Yeah, otherwise it's formal charges off, so perfect. Now, it's time we talk about resonance. And resonance structures means whenever you have choices as to where you put the double and the single bonds, draw all options. So I have two doubles and a single. I could move, effectively, I could have put the single bond right here. So draw it. And this is my double-headed resonance arrow. You don't have to make it, but it is typical. So Cl, double bond, single bond. And then my third one will have the single bonds to the left. And of course, these are resonance structures are Lewis structures, so you have to draw all the pairs of electrons and put the negative formal charge. And I will put those electrons in there this time. I almost forgot them again. There we go. Make sure I'm all on screen there. There we go. So these are all three of the resonance structures, and that's a separate question we will be coming to, is how many resonance structures do things have? But then what you need to do to find the bond order is you zoom in on one of these bonds. And we're going to look at the one on the left and count up how many bonds there are. There are 5 bonds, so this is the bond order calculation. 5 bonds and 3 resonance structures. And so 5/3 will be the bond order. And so it's quite a process, and this is, when you submit your work for this one, I do expect to see a lot of work for this, because that's just part A. Now part B, how about we try, let's try ClO+. And for ClO+, I'll do it on the back. ClO+ is a strange looking thing to us. I have never seen this ion before, or certainly not in a long time, but we can still draw its Lewis structure. I have 7 plus 6, and then I'm going to subtract 1 for the positive charge. So that's going to be 13 minus 1, that's going to be 12 electrons. I've only got 2 atoms, so I'm going to put a single bond between them, and then 4, 6, 8, 10, 12. And now I don't have an octet on my chlorine, so I will form a double bond. And that is the best Lewis structure we're going to get. Well, let's see, what else could we do? Well, chlorine I know can have an expanded octet. Oxygen cannot. If I were to find the formal charge in this species, I would say for chlorine, there are 7 valence electrons from the periodic table. There are 2 bonds, and 1, 2, 3, 4 unshared electrons. So I do get a +1 formal charge right here. And so that is the best Lewis structure. So the positive formal charge needs to be on the less electronegative atom. So, okay, now this is the best Lewis structure. There are no resonance structures. We would say that the bond order, So is going to be the number of bonds, which is 2. And we're not even going to do, there's only one structure, so I'm not even going to call it a resonance structure. I'm going to say over one structure. So my bond order is 2. And if we compare bond order, so we have Cl O3 minus with a bond order of 5/3. We have ClO plus with a bond order of 2. And so bond order of 2 is higher. So of these two at least, this has the higher bond order, the shorter and stronger ClO bond. And I've done 2 of them. Of course, there are 4 to do, and for this problem, and we would just continue this process until we've got them all. And you will be doing this process. Well, let me ask this. Are there any questions before I flip back? And so then I'll flip back. When I flip back, so you're going to be doing these for NO3 minus, the nitrate ion, and you're going to do this same process. You're going to find the best Lewis structure, you're going to find the bond order, and you're going to compare the bond orders for all 4 of them.